In today's lecture, we are going to see how we can actually code linked lists using C. So we have already discussed the main functions that we perform for linked lists, that is creation, add, delete, beginning, end at a particular position, search for an element, count the number of elements in the linked list, and print the linked list. So in this program, I'm going to show you the actual code for the linked list, and I'll run the program in the end so that you can see how the output works. So for simplicity, what I've done is I have declared my structure and my start pointer globally. So when I do that, I can access the start pointer from any function, so I don't need to pass it. So this is for simplicity in case you are asked to do it the other way by declaring a start pointer in main and then passing the start pointer either by value or by reference. You have to modify your functions accordingly. So this is the structure that is there. This structure has a data field which I have named info, and the next field which is the pointer to the next node. So this is the structure. The structure singly linked list start pointer is set to none. So this is our initial requirement. It tells us that start is null, which means linked list is not existing at the current time. If it is not null, that means there are some nodes in the linked list. In this case, I have written, these are the functions that I have written. So create list, it is just an additional function which I write to create the list the first time. It is just creating the first node, and after that you can just use insert. So insert big is insert at the beginning, insert at is insert at the end, delete at, so you want to delete at a particular position, beginning or end or any other position. So we'll take care of beginning and end in the same function. You will see later on. Traverse is just traversing or printing, finding the length of the linked list, how long or how many number of nodes are there in the linked list, and then searching for an element S in the linked list. Okay. So this is what your main program will look like. So this is a do while loop. You print this whole list in front of the user, and the user chooses an option, and based on the option there's a switch case, and you call the specific function to do the job. So create list, it is just an additional function that I've written. It is simply insert element at the beginning or the first element. So insert element, delete an element, print the list, search for an element, find the length of the linked list, or just to find if the linked list is empty. Maybe sometimes you need to check before calling a function to see if there is something in the linked list. For example, I ask you to search for a particular element, so you first see if the linked list has something inside. If it's not empty, then you proceed with your function. So enter your choice. This is a choice that the user will enter, and based on that you will call the functions. So if the user has entered case 1, which is create, you call the create list function. If the user has entered insert add, so I've just combined it. So we ask the user for the position, and we scan the position, and we see if the position is 1, we insert at the beginning. I've written two functions separately just to tell you or show you that when you insert at the beginning, it's a different case because you modify the start pointer. If it's not the beginning position, then we have to check whether the position mentioned is actually there in the linked list. For example, if your elements, there are 4 elements in your linked list and the user enters position 6, so you cannot put something in position 6 because there's no position 5. So in case you your length is not equal to 0, you insert at that position, and we'll check for that position later in the insert at function. If you ask for delete, there's a delete at function. Then there's a traverse, which will just print for you. And if you have to search, you ask for the element you want to search and pass it on to the search function here. If you want the length of the linked list, that is case 6, and So if your length is 0, your case 7 was if the list is empty. Your case 7 is, this is 7 actually, is list empty. So if the list is empty, we return a list empty, print f, or not empty printf. Okay, and default is incorrect choice, so the user is sent back. While your choice is not equal to 8, this program will continue to run. Okay, so let me compile and run it for you before we go in details to the functions. So this is what my program looks like. Okay, so I'll go by the example that I've given in my video lectures. I'll try to create a list like that. Okay, so let's say enter your choice. I want to create a list, so I enter choice 1. So enter the element you want to insert. I want to insert 5. So the insertion is done because it returns back to the menu. If you want to see what is there in the linked list, I will print, which is choice 4, and this is your first node of the linked list. Okay, I've just printed it with a dash so that you can see how it connects. So now if I try to create a linked list again, let's say I want to say I enter choice 1 and I enter 10. The list has already been created. Insert the other element. So this is a function that I have written. It works like this. You can use it just for the first time and not otherwise. So for other insertions, we'll use insert element, which is choice 2. So when I give choice 2, it asks me to enter the position. So for now, let's create the linked list that we have been using in our example. So I'll enter position 2 and I enter 10. Again, I'll do insert element position 3 and I'll enter 15. Now I want to see what has been created. So choice 4 for printing. So 5, 10 and 15. This is my linked list currently. Okay. Now let's say if you want to insert something at the beginning, so that means you have to give position 1. So let's say I want to insert an element, which is choice 2. I want to insert it position 1. Enter the data. I want to insert 50. So it's done. To see whether it's done, I'm actually printing it after this. So 50 has been entered at the beginning. So let's do insert at the end. Choice 2. I want to insert 100 at the end. Enter data to be inserted. Oh, sorry, I put a wrong position. So let's see what it does. Enter data to be inserted. I'll put 100. So if you see, I have a message here which says there are less than 100 elements, which means my insertion has not been done at the end. So this is my current linked list. So again, I want to do insert element. I want to enter the position. So if 100 has to go, it has to go at position 5. So end is position 5. Enter data to be inserted 100. So now if you print, you see 100 has been inserted at the end of the linked list. So let's see now. Let's delete at the beginning and at the end. So delete is option 3. Enter the position at which you want to delete, and I have mentioned 0 for last because the user might not always know what is the length, so you first have to check the length and then give the position as the total length of the linked list. So 0 is for last position, so let's say we say 0, and after that if we print, our 100 is gone, which was the last element. Then you enter your choice again. Let's delete 50 again. So this is 3. I want to delete position number 1, and now let's see what is there. So we have come back to our original linked list. Now let's do insert at a particular position, and then we'll delete that. So like I did in the video lectures, we'll insert 50 at position 2. So insert element choice 2, enter position 2, enter data to be inserted 50. Let's print it and see what has happened. So 50 has been inserted at position 2. Now let's delete it. So 3 is for delete, and we want to delete position 2, and what is left after deletion is again our linked list. So print choice 4 we have already used. Let's say we search for an element. So what element you want to search? Let's search for something which does not exist. I put 60. So I get a message, element 60 is not present in the linked list. So again, let's search choice 5 for 15. So I get element 15 is present in the linked list at position 3. So like I told you in the video lectures earlier, you can do both the things. Find the element as well as find its position, because you're using the same loop. You just have to use another counter to count where the element you found, where it was present. Then length of the linked list, let's see first, let's print it first. There are 3 elements, so for length we have to enter choice 6. So the length of the linked list is 3. Let's say, is the list empty? The linked list is not empty, so let's make the linked list empty. So enter your choice, delete, let's say position 1, so 5 is gone. Delete position 2, now 15 must have gone. Delete position 1 or last, so list is empty. So let's see if I can create a linked list. Let's create about 100. So let's see, yes, it has been created. So all these functions are there and they help you add, delete, insert at different positions. And then I want to exit, so exit. Okay, so now let's go over these functions one by one. We have done this uh, in parts, in snippets in our video lectures. Now this is in detail in the actual code. So create list, you declare data. This is what we are going to enter, the info field. Then we are declaring a few pointers to the structure singly linked list. So enter the element you want to delete, scanning the data. Now this is the allocation of data, malloc size of struct singly linked list, SLL, and typecasting it, struct SLL here to new node. Okay, we put the data in the new node, info field, we put null in the next field. So we have created a linked list node with the data and the next pointer set to null. So now we have not actually put it in the linked list or linked it with the existing linked list. There is no linked list as of now, because if start is null, you put start as new node. Else, if it is not null, this create function works like this, that it just lets you add a node if the list is empty. So creating means just adding the first node to get started. So you have seen this message come when we try to insert elements in a list where there are already some elements present. Then print, this is the traversal. If start is null, printf link list is empty, which is obvious. Else you copy the start to a pointer. This is our temp pointer that we have used in the loop. Like I told you, there are two types or two ways in which you can write the loops. One is pointer to next is not equal to null, and the other one is pointer is not equal to null. So if you use pointer to next is not equal to null, you have to put an additional statement outside the loop. So to avoid that, we are using while pointer is not equal to null. You printf pointer to info, the data, and then you make pointer point to the next node, and then you continue the loop. Again, length is the same way, same traversal loop. You declare a temp variable. You declare a counter for L equal to 0. If start is null, return L. So if it's empty, then you return a 0. Else you put same loop that we have written. This is loop 2. Loop 2 of what I have mentioned in the video lectures. Temp is equal to start. While temp is not equal to null, you do L++ and temp is equal to temp to next. Return your length. Okay, simple. I've already explained this. Then insert at the beginning. So again, I've split it into two functions. You don't need to do it. It was just for explanation. So You have a data, you have created or declared a pointer new node, then you, I'll put the cursor here, so I'm on this line. Printf the data, scan the data, malloc size of struct linked list, and put that address in new node to info is equal to data that you just entered. New node to next is start. So if it's at the beginning, your new node is going to be the first node, and now new node should point to the node which was actually the first node. So which is the address of the first node is in start. So you are copying start into the next field of new node, and you have to modify start is equal to new node because now this is your first node, and you return. Because start is a global variable, you can make the change anywhere in your function and you just return. In case start was not a global variable, you had to pass it in the function and then either pass the address or value, and accordingly you either return nothing or you return the value of the modified start. Insert at a particular position. So I have declared two pointers, new node and previous, of the type singly linked list. A couple of variables I, data, and j. J is the length of the linked list. So this is why I'm looking for the length of the linked list, because if the data to be inserted and if the position that has been passed to me, if that position does not exist, then I will have to work accordingly. I think insert at, I have already checked that at the beginning. Let's go back here. So your 2 is insert. So if the position is 1, we insert at the beginning, and if your length is not 0, you insert at the position, else printf linked list is empty. If it's empty, then you cannot enter that position, and in case your position is bigger than the length, even then it will be a problem. Let's see if that is taken care of here. So insert at, let's go back. So we start a for loop. You can use a while loop, you can use a for loop. I want to stop at a particular position, so I start with I equal to 1. I is less than position minus 1. I want to stop at a position before the position where I have to insert. I have explained why we have to stop ahead, and then I plus plus. Previous is equal to previous to next. So my previous is my temp. So temp is equal to temp to next. We go to the next node. If before you actually reach at the position, because this for loop will exist if you find the node which is just ahead of the position, you will exit the loop. In case while you are in the loop your previous turns to null, which means that there are less than the elements that you have specified in the position, so it will return. So that is the error check there. And once you are out, you have stopped at the position. When you're out of this for loop, you have stopped at a position before the position where you want to add. So first of all, we create a new node, and then we put the data in the new node, and then in the next field of new node, we are putting the next field of the previous node, and in the next field of previous node we are putting new node. So you can go back to the lecture notes to see how this works. These are the 2 pointer changes that we do for insertion. You have to get to the correct position and do these pointer changes based on where you have stopped, where your temp is pointing, where your other temporary pointers are pointing. You have to adjust. You should know what pointer changes to be made, and ideally when if you are a beginner in this, you should draw a figure, and based on the logic of your loop you should see where your temp stops. You should see what actual physical connections you have to break and make, and then accordingly you should write these 2 statements. These are the pointer change statements. Okay, so similarly, you have delete. So again, you enter the position to be deleted. We have mentioned 0 for last. You can implement it in any way unless you have been told in an exam to use a particular method or use a particular type of logic for start variable, whether the start is global. If it's not, if nothing is given, you can assume it is global. If you've been asked to pass the start pointer, then you modify your function accordingly. So if position is greater than the length, then you cannot delete obviously at that position. Else if position is 1, this is a special case. If position is 1 means you are going to delete the first node, and if you are going to delete the first node, the logic is different. There are not those many connections to break and make. You have to modify the start pointer. So you save the start pointer in previous, then start is made to point start to next. Why we save start pointer? So that we can free it, and then you return. So in case your position is 0, which we have specified as the last element in the linked list, in our program, that is what it means. You loop while temp is equal to start, while temp to next is not equal to null. So this is a new type of traversal loop. So we have seen while temp is not equal to null. We have seen while temp to next is not equal to null. Now this is temp to next, which means if temp to next is equal to null means you are already at the last node. But to delete the last node, we want to be a node ahead. Ahead in the sense before that last node. So the temp should be the second last node. The next of temp will be the last node and its next will be null. So that is our condition. If you see in the lecture notes, lecture videos that I've given earlier, we have used two pointers. One to retain the second last node, and one which will hold the last node, and then we make the pointer changes. This is another way of doing it. So you will stop at the second last node, and then in previous you are putting the temp to next. Temp is going to be your second last node, and if when you say temp to next, it is your last node, you put that in previous. And then temp is your second last node, so you make it point to null and you free previous here. Okay, then you are done. Else, now if we come to the case where position is somewhere in between, so again we use temp to next is not equal to null. P plus plus, P has been initialized to, I think, 1. No, P is 0. So P is 0. Temp to next is not equal to null. P plus plus, that means you go 1 ahead. If your position is 1 less than the position where you want to delete, you break out. Otherwise, you continue in the loop. Okay. Once you break out, your previous, you save temp to next, the node that you have to delete in previous. Then you put in the next field, you put next to next pointer. Okay, you can see in the lecture notes what it means, and then you free previous. Then search. If start is not equal to null, this is an essential check when you say search. It should not be null so that you can start the loop. Position is plus plus. This is the additional work I'm doing. I've been asked to just search for the element but I'm also calculating its position just as an additional information. Temp is equal to start while temp is not equal to null. If temp to info is equal to s, that is what you are searching, found is 1 and you break. Otherwise you continue in the loop and you also increment the position. So just to keep a count of which position you have reached. If found, you display the element as well as its position. If not found, display the message accordingly. So let's run it again. So enter your choice. One, create, let's say 100. So 100, let's create a longer linked list with, let's say, 5 elements. So insert position 2, 200, insert position 3, 300, insert position 4, 400, insert position 5, 500. So this is what our linked list look like. So if I say delete position 1, 100 is gone. I say delete position last, 500 is gone. If I say delete position 1, 200 is gone. Again delete position 1, 300 is gone. Delete position 1, 400 is gone. List is empty. Let's say we find the length of the linked list. Length is 0. Is list empty? Linked list is empty. Print list is empty. Then say search for an element. I want to search 100. So element 100 is not present in the linked list. Let's say let's add 100 and now search 100. So element 100 is present in the linked list at position 1. So quit. So to keep this program going, you have to write your main like this. So you can add more choices based on what you want to do with the linked list. Let's say you can add a choice called sorting the linked list. You can add a choice like uh, you can merge two linked lists. So if you have two linked lists with start pointers start1 and start2, how do you merge the two linked lists? You make the last node of list 1 point to the first node of list 2. It is just one additional pointer change and you have merged the linked list. You can have a more complicated merge where you merge the nodes alternatively. So you take the first node from list 1 and the first node from list 2 in position 1 and 2. Then again you go to the first node, first linked list, take the next node which is position 3, then second list, the next node position 4. So you can do alternate. So you can complicate your program in any way and see if you can implement that. Okay, so this ideally you should recreate this program and write it yourself and debug it so that you can learn in the process. This is also to be done by you, and actually once you will come back and we'll have some time slot for labs, this is what I would check and ask you to run in the labs so that we can grade you for the labs accordingly based on this. So everybody should have their own program written and understood well. You'll be asked questions on what you are doing and how you are doing it. Okay, so if this program is completely understood and completely working for you once you write it yourself, what follows singly linked list is doubly linked list. So you can just copy this program and modify it accordingly based on doubly linked list. I'll be taking a video on doubly linked list after this one. The next lecture will be on the functions of doubly linked list, and then we'll also see how we implement that in code in another such video. Okay, so I think I'll end here, and I hope that all of you will try uh, replicating this program, not copying it from somewhere and just running it. Just try to write a couple of functions, but you should understand that very well so that you can modify those functions and do any kind of manipulation with the linked list. So this is the end of your lecture. This is your class as well as a lab lecture. Thank you.